Hi everyone. In this given problem statement, we are going to solve lowest common ancestor of a binary tree. Let us take the example of a binary tree. Let it have value of 3, 5, 1, 6, 2, 7, 4, 0, and 8 for now. So it is going to have value, let's say, for example, in the first case, right? It is going to have a value of 5 and q would be 1. So these are the two values. So you have to find the lowest common ancestor. So for 5 and 1, right, we are going to return 3. There could be another case where p could be 5 and q would be 4. So in that case, right, so we are able to find the p at 5 at this place and the 4 is down below. So in this case, right, the lowest common ancestor, right, is going to be 5 because 5 is at the top right now. Similarly, there could be another case where p could be 2 and q could be 7. In that case, we are going to return 2 because 2 is at the top upmost position than 7. So let us take an example. There could be a situation, right, where both p and q could be on the separate nodes, right? Let's say it could be 6 and 8. So in that case, right, we are going to move up till we find a common value. So the common value is going to be 3. But in case, let's say the value is 5 and let's say our q node, right, it could be 7 or something. So we're going to go up till we reach the 5 most position, because here we can say, right, the 5 is an ancestor. So if I write the pseudocode for it, it is going to be pretty straightforward and simple. So I can do, the first thing is that if not root, then we can simply return none. But in case if root is equal to our p or root equal to q, so we are able to find a node value which is equal to p or q. In that case, we're going to return root. In the other cases, right, then we have to do the DFS, or we are going to do a recursion. So L could be, let's have a function DFS root dot left, and obviously we have to pass the p and q parameters, and R could be DFS root dot right, p and q parameters. So in case, right, we are able to find both L and R. So it can only happen, right, if they are on the two separate sides. So in that case, we're going to return root, but else in all the other cases, we are going to return L or R, because if you're able to find 5, right, in that case, the value could be present in this section or in this section. So we can keep on iterating. So out here, right, I can go on the right side. So 1 is not the value of, so 1, let's say 5 and 4, right? So 1 is not the value, 4 is not 1. We can go and traverse these values also. Similarly, we can traverse between out here till we find 4, and once we find 4, we can return it 5 value out here. So that's the basic idea. Now let us jump to the Python solution. Hi, so the first thing we're going to do, we're going to check if the root value is not present. So in that case, we're going to return none. Now we're going to check the current value of root, right? Is it equal to our P tree node, or our root is value is equal to Q? In that case, we are going to return none. Now we are going to do a traversal by recursion, so it would be self dot lowest ancestor, and the value would be root dot left with P and Q. Similarly, you're going to do the same thing for the right traversal, so self dot lowest common ancestor, root dot right, P and Q value are to be sent. Now if L and R return root, in all the other cases we are going to return L or R. So that's the basic idea. Let me run it down. There is some error, it seems. Yeah, so I made a mistake. Instead of none, right, we are going to return root. So my bad. Let me run it again. As you could see, the code ran successfully. Now all the public test cases passed. Let me submit it up. As you could see, the code got submitted, and the time complexity of it is going to be big of n because we are traversing all the nodes one time. I think if I run it again, I think it's coming 12.16. I think it can be improved, but as of now, you can say it's big of n. Okay, now it's coming 82.51. So these are very variable. So all the code that I'm writing, right? So I am trying to write with best efficiency and with the minimum time complexity. But in case there are room for improvement, do add it into the feedback section or in the comments so that the future learners can learn it through. That's all for this video. See you in the next one.